The quantum computer is a chip in this one here, but this whole thing keeps the quantum computer working at insanely cold temperatures like we talked about.
So this is all refrigerator technology.
So all of these cables that you see here on the side carry signals down through the fridge into the processor, and then they do their quantum stuff, and it comes up. And it goes to these room temperature control electronics, and they turn it into things that humans can understand.
That is a quantum computer.
I think it's really funny that when people generally talk about like the difference between classical and quantum computers, people are like, okay, well, you know how a classical computer works, right? But like the truth is that like nobody knows that. A simplification of it is it comes down to bits. And bits are made out of pieces of silicon, and you have, you know, tens of thousands to millions of them in your computer. And they can either be in the state 0 or 1. We call it the ground state or the excited state. And everything that you type into your computer, like all words, all numbers, all colors, get translated into computer speech. But it's very binary, right? A quantum computer is run on qubits.
Qubits aren't like bits. They aren't a 1 or a 0. They're more complex. Think of this like a wave. A qubit could be really likely to be 0, which means a lower energy wave. Or it could be really likely to be 1, which means a higher energy wave. And each qubit has a probability of being each. When a quantum computer is working, the probabilities of multiple qubits interact.
And they add constructively or destructively, just like waves would. If you were to like tap like 2 places in a pond, basically you are altering the probabilities while you're running an algorithm.
It's a common misconception that quantum computers try all the options. That's not right. This is simplified, but it's more like a quantum computer kind of watches the pond. It watches how all of those waves interact and then finds the most likely answer. If this is all confusing, don't worry. All you really need to know is that quantum computers calculate things very differently than classical computers do, and that makes them good at different things.